Okay, welcome along to the June 2018 Paper 6 Higher Tier walkthrough. I'll go through the full paper giving you all of my solutions. You can use a calculator for this paper, and you can see you've got the grey boundaries below to see what you need to get on Paper 6 to get the grade that you're after. So to get a grade 5 here on Paper 6, you need to get 31 marks, grade 6 is 42, 7 54, grade 8 69, and grade 9 84. So I would say this is a pretty typical grade boundary for the higher tier paper. And without further ado, let's get into it. So question 1 is Ping chooses 4 numbers. The mode, the most common of these numbers is 8. The range, the difference is 7, and the mean, the average is 11. Find Ping's 4 numbers. Now, let's begin by looking at the mean here, and to get the mean, you've got to go and add everything together. So let's make a note of this, right? The mean is equal to, you sum, you add everything up, and you divide by how many bits of data there are. So the number of bits of data that you're after, okay? Now, we know from the question that the mean is 11, so we can go and say that 11 is equal to the sum. We don't know what your numbers are going to add up to, so we can go and leave that as just a sum. But we do know that you've got 4 bits of data, so that's going to be 4. So the sum is going to be equal to 11 times 4, which is 44. So you know that your numbers are going to add up to give you 44. Now, if the mode, which means the most common, is 8, well, I guess you could have all of your numbers being 8, but that wouldn't work out, and I'll show you why. Because if they were all equal to 8, then, well, the mode is clearly 8, but what is 8 add 8 add 8 add 8? It's 32, not 44. Okay, so that definitely cannot be the case. The mode, you could have 3 8s. Okay, you could have 3 8s, but if you did have 3 8s, well, that would give you 8, 16, 24, and to get to 44, you would have 20 left. And this wouldn't work because the range, the difference, okay, range means the difference between the biggest and the smallest, is not 7. The range here would be 12. 20 take away 8 is 12, not 7. So it can't be 3 8s. So the mode must have 2 8s. Okay, it must have 2 8s. So we know straight away that there's going to be an 8 and an 8. Now, we also know that the numbers, they sum, they add up to give you 44. So 8 plus 8 plus another number is going to give you a total of 44. Now, if I go and do 8 add 8, which is 16, and bring it onto this side, we can go and say that, well, x plus y must be equal to 44 take away 16, which is going to give you 28. Okay? Now, the thing is here, right, if the range is 7, right, and we know that 2 of our numbers are going to be 8, well, the biggest possible number that one of the numbers could be would be 8 plus 7, okay, which would give you 15. So the biggest possible value it could be would be 15, and the smallest possible value one of our numbers could be would be 8 take away 7, which would give you 1. Now let's just go and say that I choose the biggest possible outcome, which would be 15. Then my numbers would be 8, 8. So I'm doing a bit of trial and error here. And if I did use 15, well, the remaining number, well, 8 add 8 is 16, add 15 is 31. To get to 44, that would leave me with 13 left over. Now let's just see if this combination works. Is the mode here 8? Well, yes it is. You've got 8 twice, so that one is satisfied. Is the range 7? Well, the biggest number, 15, take away the smallest, it does give you 7, so that's good. And the mean would be 11, because 8 add 8 add 15 add 13 gives you 44, and 44 divided by 4 gives you 11. So actually, right, I've hit it pretty early on, which is good. But you would see, right, if you tried something else, like if you tried, I don't know, 8, and let's just say you tried 12, then this number would be 8, 16, 28. Your other number would be equal to 16 to get you to 44. And the range here wouldn't be 7. The range would be 16 take away 8, which would be 8. So you would see that this wouldn't work out. Okay, so we got there pretty quickly, but these here are going to be your 4 numbers. So 8, 8, 13, and 15. And that is the first question. Good. Question 2, a bit of ratio. We've got the box contains only red, blue, and green pens, and the ratio of red to blue pens is 5 to 9, and blue to green pens is 1 to 4. Now I can see here, this is a classic double ratio question with the common thing here being blue pens. And the question is saying calculate the percentage of pens that are blue. Now, with ratio, write up what is going on. You've got red to blue pens, which are in the ratio 5 to 9, and you've got the ratio of blue to green pens, okay, which are in the ratio 1 to 4. Now, because blue is the common thing in the ratio here, you want the blue parts to be the same. And I know that if I times the second ratio by 9, we're going to get a common number for blue. So 1 times 9 is going to give me 9, and then 4 times 9, of course, gives you 36. So you now know whenever you've got 9 blue pens, you've got 36 green pens, and you also know when you've got 9 blue pens, you've got 5 red pens. Okay, so that's the ratio of red to blue to green, 5 to 9 to 36. Now the percentage of pens that are blue, you know that you've got 9 blue pens, okay, and percentage is out of a total, so add all of these parts here together, okay, add these together, and we get a 5, add 9, add 36, and to get it as a percentage, you multiply through by 100. So it's going to be 9 over 14 add 36, which is 50, okay, which is actually, you could times it through by 100 here, okay. You might recognize that's 18%, but if you times that by 100, you're going to be getting 18% of the pens are going to be blue. Check the mark scheme. We are good. 18% is correct. Excellent. Good, good, good. Question 3, we've got this. Aisha worked out this calculation that you can see up here. She got an answer of 19.5 correct to 3 significant figures. Write each number correct to 1 significant figure to decide if Aisha's answer is reasonable. So this is actually right, just saying if you round to 1 significant figure, you are basically estimating. Okay, and if we round each of these numbers here to 1 significant figure, let's see if we get an answer close to 19.5. Now your first number is 326.8. Your first significant figure here is your first number that isn't a 0, which is the 3. Okay, and when you round numbers, you look to your number to the right. Okay, and if this number is 5 or more, you round up, and if it's 4 or less, you round down. Okay, so because the 2 is less than 4, you keep this as a 3. Okay, so we're going to say that's approximately equal to 3, and you replace all of your numbers afterwards with zeros. So 300, 300.0, which of course is just the same thing as 300. And you've got to go and do this for all of your numbers. So you've then got 6.94, okay, where your first significant figure is the 6, and you look at your number to the right, which is a 9, which of course is bigger than 5, so the 6 becomes a 7, and the numbers afterwards become zeros, so it's going to be approximately equal to 7.00, which of course is just the same thing as 7. You've then got 3.4. Again, same thing. Your first significant figure here is the 3, and because 4 is 4 or less, you round down. You keep this as a 3 and say, well, you've got a 3. The 4 becomes a 0, so just 3.0, which is 3. You then got 59.4. Again, your first significant figure is the 5. The 9 is going to make the 5 round up to a 6. So we're going to go to 6, replace the numbers with 0, so 60.0, which of course is just equal to 60. So now putting these numbers in for what we've got up here as our estimations, we're going to be getting 300 and then timesing it by the bracket, which is going to be 7 take away 3, all being divided by 60. Okay, and then this really is just a bit of BODMAS, isn't it? Okay, this is going to be a little bit of BODMAS, so, or BIDMAS, brackets, indices, division, multiplication, addition, and subtraction. Okay, so brackets, indices. Now, because you can see you've got a bracket here, brackets comes first, so we're going to go and do that bit first. Okay, so we've got 300 times by 7 take away 3, which is 4, divided by 60. And now this is going to be nice and easy. 300 times by 4 is 1,200, divided by 60. Okay, we can actually just go and knock off a 0 here, and say we've got 120 divided by 6, which is equal to 20. So that's equal to 20. So I would say that is Ash's answer reasonable? Yeah, because 20 is very, very close to 19.5. So I would say, is the answer reasonable? Definitely yes, because 20 is very close to 19.5. Good. Ready to move on. Question 4. Indices. Nice. We've got this. So show that a to the 5th times by a cubed all to the power of 2 can be expressed as this. Now, we've got a couple of laws of indices going on here. This here is the power law, which just states that if you have an indice raised to some power raised to another power, you simply just times the exponents. Okay, so you just times them. So this first part, or the second part here, that's just going to go to a to the power of 6, because 3 times 2 is 6, and you've got a to the 5 timesing this also. And of course, this is the multiplication law, which just states, okay, I'm probably going a bit overkill here, if you're timesing with the same base, okay, the general law is you just add the powers together. Okay, so we're just saying here, you've got the same base, okay, you've got a and a to the power of 5 and 6, which is 11. So you've shown that, well, this times by this gives you this. Okay, so there we go. Excellent. You know what, probably just to be really careful here, right, I should have really written a to the power of 3 times 2 gives you a to the 6. Okay, just to make it really, really clear that I know what is going on. But that should be fine. That is good. Now, part B is to write 1 over 125 times 25 to the 9 as a power of 5. This means that your answer, okay, must be 5 to some power, okay, where we're trying to find that power. Now, this is recognizing that 125 and 25 can be written as powers of 5 because 125, right of it, 125 is the same thing as 5 to the power of 3. Okay, 5 times 5 times 5 is 125, and 25 is 5 squared. Okay, now if I kind of rewrite this a little bit, we've then got 1 over 125, which is 5 cubed, times by, let's write that a little bit neater, so times by 5 to the power of 3, times by 25, which we've just said is 5 squared. Okay, so I'm replacing the 25 with 5 squared, and that is all to the power of 9. Now, this is the negative power law, okay, and that law is if you've got a number raised to a negative power, you do the reciprocal of that number to the power. Okay, so this is a really important rule here. So I can write this as 5 to the power of negative 3. So this and this, they mean the same thing. I've just written this in terms of a negative power using this law. And then we know from the first question that if you've got a power to another power, you multiply the exponents. So this is going to go to timesing it by 5 to the power of 2 times 9, which gives you 18. And then, of course, again, this is the multiplication law for the laws of indices with the same base. You've now got the same bases here. You add the powers. So minus 3, add 18, or 18 take away 3, is going to give you 5 to the power of 15. So this is your answer. So 5 to the power of 15. Okay, and let's check the mark scheme, no mistakes. Yeah, we are all good. Correct. Question 5, we've got this. So the diagram shows a straight line that passes through the points A and B. So that's this line here, going through A and B. And a curve, this quadratic here, that goes through the points P, labelled here, and Q over here. Find the equation of the straight line. Okay, so equation of a straight line, which is this point over here. The equation of a straight line is, of course, in the form y is equal to mx plus c, where, just to make it really clear, the m part is the gradient of your line. Okay, the gradient, and that just means the rise over the run, or you can think about it as the change in the y coordinates over the change in the x coordinates. Okay, and the c part, that is the y intercept, that is where your line crosses the y-axis. Now let's begin by getting the gradient part, m. Let's go and do that up here. Okay, so the m, now let's go and begin with this coordinate, the y coordinate here. Let's go and call it, right, the 4x, the first x coordinate, and the 5, the first y coordinate. And here we've got the second x coordinate, and here the second y coordinate. So the change in the y coordinates, let's go and do 5 take away 2. So 5 take away 2 over, and because I started with this coordinate, okay, I've got to start here for the x coordinate, 4 take away 0. So 4 take away 0, so that's going to give you 3 over 4. And I would leave my gradient as a fraction. You could write it as a decimal, but fractions are much easier to work with. And the y-intercept is where your line goes through the y-axis, which this one's nice and easy because they give you the x-coordinate is 0. It just passes through y at the point 2. So the c value is equal to 2. Therefore, the equation of your line is going to be this. Y is equal to m, which you know is 3 over 4, x, and your c value is plus 2. And that is your answer. Good. And there we go. Excellent. Part B is this, the equation of the curve, y equals x squared plus kx plus 8. Okay, so that's the equation of the curve. And find the value of k, so there's k value here. Now, you're told that the point P goes through this curve. Okay, so that's minus 4, 12. So we know that the point minus 4, 12 goes through the curve, okay, where the minus 4 is the x coordinate and the 12 is the y coordinate. So basically, you're just going to go and put in x is minus 4, in for x and x here, and y is 12, in for this value up here. And if we do this, we're going to be getting y, which is equal to 12, is equal to x squared, okay, and x is minus 4, so you get minus 4 squared plus some value k times by your x value, which is minus 4, and then you're adding on that 8 on the end. So 12 is equal to minus 4 squared gives you plus 16. This is going to go to minus 4k, so minus 4k plus 8. So 12 is equal to 16 plus 8, which gives you 24. So 24 minus 4k. Let's get the 24 onto. Let's get the 24 over here by taking away 24. So you get 12 take away 24 is minus 12 is equal to minus 4k. Now to get k on its own, you've got to go and do negative 12 and divide it by negative 4. You are dividing two negatives. Okay, so you're going to get a positive answer of 3. So 3 is your answer. Okay. Part C is this. Diane draws the line BQ. Okay, let's go and see what that is on. So she goes and draws a line B to Q like this. There we go. And Diane is saying that triangle ABQ is isosceles. So this triangle is isosceles. Let's go and see what that even means. So that is this triangle, A to B to Q. So this triangle is isosceles. Is Diane correct? You must show your working. Now you could do this in different ways, but to prove that something is isosceles, it must have two equal sides, okay, and also two equal angles. Now for me, I think the easiest thing to do here is to prove that it's got two equal sides, and I'll show you how you would do that on here. So I'm going to go and prove, hopefully, that Q2B sorry, I don't know what the value of Q is. Oh, this is a good question, right? So I can get the value of Q because, right, this is the point where the quadratic cuts through the y-axis, okay? And I know that it passes through at the point 8, okay? Because basically, right, when x is 0 here, that's going to give me where the quadratic cuts through the y-axis. So I know that this point Q is going to be 8 because when x is 0, that would go to 0 plus 0. So y would be equal to 8. So I know that this point Q here has got the coordinates 0, 8, and that's going to be quite useful. Now, to prove that this length here and this length here are the same, right, I'm actually going to be using a bit of a Pythagoras. Okay, so basically, what I'm going to go and do now is to get from Q down to B. Well, I know that this distance here must be, well, x is like the horizontal part, is 0 going to 4. That must have a distance of 4 across, okay? And it must have this height here. Well, to get from 5 up to 8, it must have a height of 3, okay? And also, if I go and draw in a triangle from A to B, and remember, it's not to scale, which is why this looks a little bit funny. I'm actually going to go and get rid of these parts now because it might look confusing. Ooh. In fact, let's just go and draw this in again. There we go. And then down, there we go. Now, to get from, again, 0, which is the x coordinate, to 4 across, again, that's got a distance of 4. And the height is going from 2 up to 5, which is up by 3. And if I go and use Pythagoras now, you've got the same triangles here. You've got a 3-4 triangle. You've got a 3-4 triangle. Okay, so we can go and say that, well, the length from Q to B, okay, so length Q to B is going to be, using Pythagoras, we can say that, well, Pythagoras is a squared plus b squared equals to c squared, and of course, right, this is going to be side A, that's going to be side B in either order, doesn't matter, and that's going to be side C. So it's going to be, A was 3, wasn't it? Sorry, 4, so 4 squared plus b squared, which is 3 squared, equals to c squared, so 16 plus 9 gives you c squared, so 25 equals to c squared, so c equals to root 25, which equals to 5. So the distance QB is 5, okay, so this here is equal to 5, and because you've got the same triangle here, right, it's 4 across 3 up, you're going to get this also being equal to 5, so AB must also be equal to 5. So because QB is equal to AB, let's go right over here. So we can go and say that QB is the same length as AB, and they are both equal to 5, which I've shown through my Pythagoras working. Okay, there we go. Excellent. I don't have to go through the work again because literally it's the same calculation for AB. It's the same triangle, so that should be sufficient to prove that I've got 2 equal sides, okay, on my triangle. This is equal to 5, and this is also equal to 5. Excellent. Good. Question 5. 6. We've got this. Y is inversely proportional to x. When y equals to 0.04, x is 80. find y when x is 32. So this is your typical sort of proportionality question. Now, if y is inversely proportional to x, you say that y is proportional to 1 over x. Okay, and as an equation, that is y equals to k over x. Okay, now you put in your values into your equation. So when y equals 0.04, you put it into this. So you get 0.04 is equal to some constant value k over x, which is 80. So to get k, it's going to be equal to 0.04 times 80, which equals to whatever it equals to, 3.2. So now you know that your k value is equal to 3.2. So kind of going back up to your equation, we're going to be getting y is going to be equal to, we now know that your k value is equal to 3.2. So 3.2 over x. And we're going to be replacing x with 32. So I can go and say that y is equal to 3.2 over 32. So y is going to be equal to 3.2 divided by 32 gives you 0.1, and that should be correct. That is correct. Okay, so a pretty standard question here on proportionality, so good stuff. Excellent, moving on. We've got this. Edsel has got 4 number cards, 3, 8, 9 and 12, and Sharon has got 3 number cards. U represents a number that Sharon knows. Okay. Edsel and Sharon each pick one of their number cards at random. They calculate the difference, okay, which means a subtraction then, between the numbers on the card. This is their sample space. Now, is the difference Edsel's take away Sharon's or Sharon's take away Edsel's? Well, let's check the table. It's going to be Sharon's take away Edsel's, because like 6 difference means take away 3 gives you 3. If you did 3 take away 6, it would be minus 3. So it's going to be Sharon's take away Edsel's. Okay, that's quite important to note. So let's check another one. 11 take away 8 gives you 3. Find the values of R and T. Okay. Now, the thing is, right, to get R and T, I've got to get U first, because like some number U take away 9 would give you R, for example. So if I go and do U take away 9 gives me R. U take away 9 gives me R. Well, the issue is I've got 2 unknowns here. And similarly with, like, if I go and do, I don't know, U take away 12 gives me T as the other one. Well, again, I've got 2 unknown things, which isn't useful. But what I can do is this. I know that U take away 3 gives me 11. Okay, so I know that U take away 3 gives me 11. Therefore, U must be 11 plus 3, which is 14. So now I can go and replace U with 14, and this should now be quite straightforward. So with the first one, we've got U is now 14. So 14, let's go and kind of, where shall I write this? Let's write it, let's go and call it right. No, let's just go and write it down here. So we've got, for the first one, you've got 14. So I'm just trying to think where to write it, so it doesn't look confusing. I'm going to write it up here. 14, take away 9 gives you R. Therefore, you know what, I'm going to write it up here. 14, take away, no, I'm not, sorry, I'm being really silly about this, right. For this one, we've got 14, take away 9, it gives you R. Therefore, R must be equal to 5. Okay, so that's your R value, 5. And then similarly for this one here, by putting in U as 14, we've got 14, take away 12 gives you T. So T is equal to 2. And that should just be it. Okay, 5 and 2. That is correct. Excellent. Moving on. Question 8, you've got a speed time graph. Now, whenever you see, I'm not even like, I always say when I see a question, I don't even read the question. I'm just trying to spot what could the question be about. And whenever you've got a speed time graph, 2 things. that jump out to me is that first of all, that the gradient, okay, of a speed time graph is equal to acceleration, and also the area under the graph is equal to the distance travelled. So I'm not even reading the question, but I just sort of know through experience and through exam paper practice that this probably will be useful at some point. But the graph shows the speed of a tram as it travels from the library to the town hall. Okay, calculate the deceleration, there you go, straight away, of the tram as it approaches the town hall. So that must be this part here, because deceleration is negative acceleration. So, and this is a negative gradient. So we're looking at this part here for deceleration. That's deceleration, that's acceleration. Now, to get the deceleration, which is the gradient, okay, well, that's going to be equal to, gradient is like the rise simply over the run, put in a really simple way. Now, the rise here is like up by 6, okay, so how tall it is, up by 6, so 6, and the run is really what I should go and do is I should choose a point and choose another point. So now to get from here down to here, the run is going across by 20, because 65 to 85 is across by 20. That's your run. And then really, okay, because I've gone across by 20, I've gone down by -6. So the rise should be -6. Okay, but it's just recognizing that this is a negative gradient. And this is equal to 6 divided by 20 gives you 0.3, so minus 0.3. So the acceleration is equal to, the acceleration is negative 0.3, but the deceleration, okay, you take the positive of this because the deceleration already takes into account the negative. You would just go and write 0.3, and that's your answer, hopefully. That is correct. Good. Now part B, there you go. Calculate the distance travelled by the tram between the library and the town hall, which is the area under the whole of this speed time graph. Okay, so all of this stuff here. Now basically you're just getting the area of triangles here. You've got shape 1 and shape 2. Okay, so now for shape 1, you've got triangles here. It's going to be the area of shape 1 is going to simply be half base times height, so half times the base of this triangle, which is 65, times by the height of it, which is equal to 6, and that's equal to, well, 65 times by 6 is equal to 390, and divided by 2 is 195. So area 195, going to be meters for distance, and then for triangle 2, the area is going to simply be equal to a half times, again, the base, which is 20. So times by 20, times by the height, which of course, again, is just going to be 6. 20 times 6 is 120. Half of it gives you 60. So that's going to give you 60 meters. Okay. Now, to get the total distance travelled, you just go and add these two together. So you go and add the 195, add the 60, which gives you whatever it gives you. So the total is going to be 195, add 60. Total is going to be 195 plus 60, which gives you an answer of 255, and that is your answer. 255 meters. Okay. Good. Check the mark scheme. We are good. Part C. What was the maximum speed of the tram as it travelled between the library and the town hall? Give your answer in kilometres per hour. Now, the maximum speed was this point up here. Must have been. That's when the speed is literally at its biggest, but it isn't. This is in meters per second. So the maximum speed was 6 meters per second. Okay? You want to get this answer into kilometers per hour. And the way that I go through this is like this. Well, you're trying to get kilometers, you've got meters. Now, let's go and do this over here. Now we know that in 1 meter, sorry, in 1 kilometer, right, there are 1,000 meters in 1 kilometer. Okay, now the reason I can times this fraction, the reason I can go and times 6 by 1 over 1,000 is because you're timesing this number by 1, because 1 kilometer and 1,000 meters are the same thing. So you're just timesing 6 essentially by 1, because this is the same thing. Okay, and this is good because, well, the meters here and the meters here will cancel, because when you're timesing fractions, you can cross cancel on the numerator and the denominator, and you've got kilometers, which is good. You want hours, and you've currently got seconds. Now, we know that in 1 hour, well, in 1 minute, there's 60 seconds. In 1 hour, there are actually 3,600 seconds in 1 hour. Okay, in 1 hour. And again, you can times through by this because 3,600 seconds is just 1 hour. You're timesing through essentially by 1. So you can do this. Now, of course, here the seconds units and the seconds up here will cancel, and this is good. You've now got kilometers per hour. So we've got 6 times 1 times 3,600, which is just 6 times by 3,600, and the unit is kilometers, which is good. Kilometers, let's keep it in blue, sorry. Kilometers, and this is all being divided by timesing fractions. You've got just 1,000 on the bottom times by 1, which is just 1,000, and then of course that unit is hours. So that's good. And then put this into your calculator, and you're going to be getting whatever you get. 21.6, so 21.6, and you've got kilometers per hour. So kilometers per hour, which is the exact unit that you want, which is really, really good. Okay, so 21.6. There we go. Question 9, we've got this. The graph of y equals x cubed plus 7x minus 12. So it's a cubic, because you've got the highest power as a 3, as you can see is shown below here. And the root, this is another word for solution, which means where it cuts the x-axis, okay, which is this. This is the root, or the solution here, of the equation is p. Okay, and it says calculate y when x equals to 3, part A. So you just go and put x equals to 3 into the equation up here. If we do that, y is going to be equal to x cubed, so 3 cubed minus 7 times by 3, and then take away 12. So y is going to be equal to 3 cubed is 27, take away 21, take away 12, and if you do this, you're going to be getting minus 6. Okay, so that's going to give you minus 6. That's the first part, minus 6. Now part B is saying show that P, which is the solution, okay, is between 3 and 4. Now this is basically just saying, right, this point here is going to be between 3 and 4, okay? And if this is true, if there is a solution between 3 and 4, basically it's saying, right, when you go and put 3 into the equation, when we did that on part A, when you put x is 3 into the equation, you got out minus 6. So you put in 3 and you got out minus 6, which is this value down here, which is negative. So you get minus 6, okay? And if you go and put in 4 into the equation, right, and if we just kind of kept drawing this graph up a little bit higher so they meet, okay, this, okay, that's a terrible drawing. Let's make it a little bit thicker. There we go, up here, something like that. Yeah, and then up here like this. right, you're going to be getting out some other y value, right, which is going to be positive. And because there's going to be a change in sign between 3 and 4, from a negative solution up to a positive for y, there must be a solution between 3 and 4. Okay, you get like a change in sign. So I've got to go and put in now x equals to 4. X equals to 4 into the equation, and I'm going to be getting out a positive value, hopefully. I don't have to do this. I'm going to be getting y is equal to x cubed. Well, x is now 4, so 4 cubed minus 7 times by 4, take away 12, so y is going to be equal to 4 cubed is 64, take away 28, take away 12, and this gives me, whatever it gives me, 24. Okay, so when you put in x is 4 into the cubic equation, you get out a y value of plus 24. But the key thing is here, right? What you've got to go and state to the examiner is this. The change in sign. Okay, so that just means you've gone from negative 6 to plus 24, means there must be a solution between 3 and 4. Okay, so that's like a key phrase, right? To show that there's a solution between 2 points, there's got to be a change in sign. Okay, there we go. And then part C here is find a smaller interval. Okay, that contains the value of P. You must show your calculations to support your answer. So in this part, right, the interval was between 3 and 4. You now want to basically, right, get even closer. And I'm going to go and get out a magnifier here. Basically, right, you want to get even closer. Right, we've gone between 3 and 4. You want to get a more accurate interval here. So basically, you want to go to like 1 decimal place. Let's go and try between 3 and 3.1 to begin with. Okay, so let's get rid of this. Let's go and try, well, this time let's go between 3 and 3.1, okay? Because this is going to be so let's try when P is between 3 and 3.1. Okay, and basically you just go and put this into your calculator. And to help me speed this up a little bit quicker, let's get this on the screen. And let's also make a note of the equation again, which is y equals x cubed minus 7x minus 12. X cubed minus 7x minus 12. Okay, so when we do this for the first one, when x is equal to 3, okay, we're going to be spitting out, let's just go and whack it into the calculator. Okay, so x cubed, so it's going to be 3 and then to the power of 3, take away 7 times by 3, okay, take away 12, we get minus 6, okay, so you get y being equal to minus 6, which the key thing here is this is negative, and if we go and try x being equal to 3.1, if you get a different sign here, like positive, that's going to be good. Let's see what we get though. So I'm just going to go and simply replace, on my calculator, can I do this effectively? I can't edit my answer. Oh, I can, good. So let's go for now 3.1. Take away this, and I get this, okay, which is minus 3.9, whatever. But the thing is, right, because they're both negative, that means that if I kind of go back again, right, I chose 3, well, 3.1 would be like somewhere here. There is no solution between 3 and 3.1 because they both give me negative output. So this doesn't work. So then you just go up to your next interval. Let's now go and try P being between. Let's go for 3.1 and 3.2. Okay, so when x is 3.1, we already know that you get a y value of minus 3.9, which is negative. Let's go and now try when x is equal to 3.2. and see what you get out. So over here, let's just go and type this in. So instead of 3.1, I'm going to change it to 3.2 and see what we get. And your answer is still negative, so that's no good. Okay, so you get y equals to negative 1.632, which is still negative. So because, sorry, this minus VE, it means negative. I should have really written that, right? That just means minus VE. That's how I write negative. Okay, just to speed things up a little bit. But anyway, the key thing is everything is negative, so that isn't particularly useful. Let's go to your next interval, and hopefully we're going to get there pretty soon. Okay, so let's go for between 3.2 and between 3.3. We know that when x is equal to 3.2, we got out y being equal to minus 1.632. When x is equal to 3.3, what do we get? Let's have a look. So, let's have a look on here. Let's put it into this. 3.3, change that to 3.3. Okay, there we go. Good. It's positive, which is really good. So y goes to 0.837. So you go from a negative solution up to a positive, which means that P must be between 3.2 and 3.3. So that must be between 3.2 and 3.3. So literally, you have found a smaller interval where the solution would go between. So just to put that into context, sorry, get rid of that. If I get the magnifier out again, there we go, on here. Literally, the solution, right, must be, can I draw over this? I can't, right, it's going to be like, if I just really zoom in over here and get rid of this, that's not very useful, is it? If I really, really zoom in, okay, the solution, right, we know it's between 3 and 4, but even more accurately, okay, we know that it's going to be like between 3.2 and 3.3. You could even go even more accurately, okay, but the question is just asking for a bit more of an accurate one. And you'll see when you go and do A-level, if you do A-level maths, you can use iterative methods to hone in on what the solution would be. But anyway, for the time being, we know it's between 3.2 and 3.3. Okay, it's between a negative and a positive value. There we go. Good. And check the mark scheme. Yeah, that's fine. That looks good to me. Question 10. We've got this. Two vectors A and B. So a vector A and vector B are shown on the grid. Show that the vector A plus 2B has a length of 7. Now, vector A, okay, we can go and say that, well, first of all, write vectors, just so we know, right, the top number in a vector is horizontal movements, okay, and to the right is positive, to the left is negative. The bottom number is positive movement, down is negative. Now, for this vector, we start at this point here. You follow the direction of the arrow, so you're going this way. Now, you're going across by 1, 2, 3, 4, up by 1. Okay, so it's the vector A you can write as across by 4 and up by 1. And vector B, just be a little bit careful here, the direction. You follow the arrow. You start here, we go across by minus 1, minus 2. Left is negative, so across by minus 2, up by 1, 2, 3. So vector B is minus 2, up by 3. Now we've got this vector A plus 2B. Okay, so the vector A plus vector 2B. And notice I'm writing a line underneath these letters here because vectors, when they are typed up, are in bold, but you can't write in bold. So you represent the vector A as A with a line underneath it. So these mean the same thing, but you can't write in bold, so you write with a line underneath it. Now this is going to be equal to, well, vector A is just equal to 4, 1. And you know what, actually, right, I didn't need to do this. What am I doing? I've overkilled this a little bit. Vector A, I can just go and draw over here. Okay, so, no, actually, no, that's probably not a bad thing to do, right? Sorry, vector 2B is going to be 2 lots of B, so it's going to be twice the minus 2, which is minus 4, and 6. Now, a plus 2b, vector a is just the same thing again over here. And you can put a vector anywhere in space, so let's just go for over here. And it's going 4 across and up by 1, so there we go. Okay, and you must show the direction. There we go. Okay, this is vector a. Okay, and we're adding on to this vector 2b, which I can go and connect from the end of vector a. Okay, and vector 2b is going across by minus 4. Ooh, let's go and do it in blue. So across by 1, 2, 3, 4, and up by 1, 2, 3, 4, 5, 6, up to here. So across by 4, up by 1, 2, 3, 4, 5, 6, and this is vector 2b going in this direction. There we go. Okay, so we're doing a plus 2b. Okay, and we can see that, well, this length here, let's go and do it in green, is literally 1, 2, 3, 4, 5, 6, 7 squares. Okay, so this has a length 7. Okay, this is literally 7 centimeters. In bold, 7 cm, because we know that each square is 1 centimeter. So there we go. You've shown that the vector a plus 2b has a length of 7 centimeters. Okay. Good. Question number 11. We've got this. The diagram below shows 2 triangles. Okay. Triangle ABC and triangle ACD. Prove that triangle ABC is congruent to ACD. Now, congruent means that the triangles are identical. Now, if triangles are identical, you've got the 4 rules that we need to know is that all of the sides are going to be the same, so they're SSS triangles, or it could be you've got a side angle and a side that are the same, or it could be angle, side, angle, or it could be a right angle, hypotenuse, and a side. Now, with this triangle ABC, I can get this missing angle here quite nice and easily by just saying this is going to be equal to angles in a triangle add to 180. So 180 take away 80, take away 56 is going to give me 44 degrees. And same sort of thing over here. Okay, with this angle, I can go and get quite easily by just doing angles in triangle ACD would be 180, take away 80, take away 44, which will just give me 56, and this is now good. So actually, right, because both of these triangles, they share this line AC, which is a common thing when you prove things are congruent. They share this line, and because they've got angle 56 and 56 and 44 and 44 that are the same, these are going to be, so you've got here, you've got a side, let's go and write it in bold, you've got a same side and a same side over here, you've got another same, sorry, what am I talking about? These angles. You've got identical angles, okay, both 44. You've got the 56s, which are also identical, and they are sharing a common side, AC. So we can go and say that these are going to be ASA triangles, okay, because they literally have identical angles, okay, they share a side, identical angles here. These are ASA triangles. Okay. Now, I guess we could be even more formal about this. Okay, and do the following. I can go and say this. Being a bit more formal, they share side AC. Okay. There we go. And also we can go and say that angle CAD is equal to angle ACB which are both equal to 44 degrees. Okay. And also we've got angle ACD. Angle ACD must be equal to, so that's this one, ACD is equal to angle BAC. BAC, which is equal to 56 degrees. Therefore, okay, they are literally ASA triangles. ASA. And that is your proof. Good. You have to write, sorry, you should make sure that you write this here. This is, you do need to write this. Okay, that is important. But there we go. Question 12, we've got this. The diagram shows two right-angled triangles, as you can see. Prove that triangles PQS and QRS are similar. Now, with similar triangles, you can prove either one of two things. Either that, well, if triangles are similar, then the lengths are going to be, kind of like multiples of each other. That's one way of proving that they're similar. Or similar triangles will have identical angles. Okay, so that's right. Actually, it's going to write the same angle. So you can prove this in different ways if they're similar. Similar means that they're like upscaled versions of one another. Okay, now you could prove that the lengths are identical. Sorry, are multiples of each other. I'm gonna go for that the angles are the same. Okay, so that's what I'm gonna go for. Let's begin with triangle QRS. Okay, I'm gonna go and draw triangle QRS up here. Okay, QRS. This one. There we go. Where this is my right angle. Now, I know that this here is 4 and this is 8. And let's just go and say I want to go and find this angle here, X. Okay, this is going to be SOHCAHTOA. You're trying to find an angle. You've been given sides, and opposite the angle is going to be my opposite side, and this must be the adjacent side because this would be opposite the right angle, the hypotenuse. Now, we've got our SOHCAHTOA. Our SOHCAH and then TOA. This is going to be TOA because you've got O and A. It's going to be the last one, TOA. And we're trying to, and what I would do here is I would write out my equation triangle. So there we go, there we go, there we go. You could have found this angle also, doesn't make any difference. But I've just gone for this one. And let's go over here. And we know that the T stands for tan of the angle O over adjacent. So we're trying to find the angle, which is the tan part. So we can go and say that tan of the angle is equal to opposite over adjacent. So tan, I've called the angle X, so tan X is equal to opposite, which I've got for 8 over 4, my adjacent. Okay, so X is going to be equal to the tan inverse of 8 divided by 4, which is 2. And if I do this, I get an answer of 63.4 degrees. So this angle here is 63.4 degrees, which means I can also go and get this angle by knowing that angles in a triangle add to 180. So it's going to be 180. Take away the 90-degree angle, take away 63.4. And that would give you 26.6. Okay, there we go. Now, basically, right, I've just got to go and do trigonometry again. Ooh. Okay, right. Which is fine to get this angle or this angle. It's actually quite a big question, this one, because I've just realised I've got to get in this triangle, okay, QPS over here. There we go, bam, bam, and then bam. Actually, I've only got one side, which is 10 here. And I've got a right angle. I need another side to get an angle. But that's fine. I can use this triangle again and use Pythagoras. So just quickly up here, Looking at the first triangle again, we've got this, and we've got this. Where here is my right angle. I know that this is 4 and this is 8. I want to go and find this side here. Okay, it's going to be Pythagoras, so that's going to be C opposite the right angle, and A and B over here. A quick bit of Pythag, okay, to go and get that longest side. So A squared I've got as 8, so 8 squared plus B squared, 4 squared, is equal to C squared. So 64, 64 add 16 equals to C squared. So C squared is going to be equal to 80. So C is going to be equal to the square root of 80. Now I'm actually going to go and leave this side here in terms of a square root, so I don't get any kind of rounding issues going on. So this side here is equal to root 80. So I know that down here, this is going to be root 80. Now, hopefully, if I go and find either this angle or this angle, I will get 26.6 or 63.4, hopefully. I'm going to go and get this angle here, because why not? I'm going to go and call it angle Y, because I've already used X up here. Okay, so there we go. And again, trigonometry, because you've now got an angle and two sides. Side opposite the angle is your opposite side. O, that must be the hypotenuse. This time we're using O and H, which is SO. So let's go and do that over here. Equation triangle. There we go, there we go, there we go. There we go, there we go. So the S stands for sine of the angle O over H. We're trying to get the angle part, so that's going to be sin of the angle is opposite over hypotenuse. So sin of the angle Y is O, which is root 80 over 10. Now to go and get Y, you've got to go and do the sine inverse of this here, root 80 over 10. And I'm keeping it in this form because I won't get any rounding issues. So the angle here hopefully will give me either this or this. Otherwise, I'll be panicking a little bit. Root 80 over 10. And we do get excellent. We do get 63.4. So I know that this angle, which is this one here, is equal to 63.4, which must mean that this angle here, because 180 take away 90 take away 63.4 must give me then 26.6. So these triangles, they must be similar, because we said that, right, if your angles are the same in your triangles, they must be similar. Yeah, because if you make a shape bigger, okay, so literally if you go and make a shape bigger, okay, like from this to this, if they're similar, the angles, okay, the angles will all be the same. They won't change. That's an important fact. Okay, so just to write this formally, let's go and say in formal notation, let's go and say that, well, angle QRS is equal to angle PQS, okay, which are both equal to 90 degrees. We've also got angle RQS is equal to angle QPS, which is equal to 63.4 degrees. And you've also got the last one, which is angle RSQ. SQ is equal to angle QSP, which is equal to 26.6 degrees. Therefore, the triangles must be similar because all of the angles are the same. Okay, that is quite a nice question. Quite a lot of working. I mean, I suppose it is 5 marks. Okay, but yeah, key facts. If things are similar, either you could prove that their lengths are multiples of each other, or all the angles are the same. I went for this one because I'm not really sure why. I just felt like that would be a better one to do. But we got there in the end, which is the most important thing. Okay, question 13. Nice, you've got a sphere which is here, and it's got a radius of 6, as you can see. calculate the volume. Okay, nice and straightforward with this one. Given this formula, the volume V is going to be equal to 4/3 times by pi times by the radius, which is 6, and then we're cubing it, so that's going to be equal to 4/3 times by pi times by 6 cubed is 216. To be honest, just whack it into your calculator, because it will give your answer in terms of pi, which is what I like to work in. So just go and type in 4/3 times by shift and then pi times by 216, and there we go. There you go, 288 pi. Okay, so it's not asking us to round to anything specific. So you can go for either 288 pi, or as a decimal, you could have written it as something like this, 904.3.8. Okay, 904.8. So something like, or even like 905. Okay, if you rounded it to 3 significant figures, but it's not asking for any rounding. I would personally give my answer in terms of pi because it's easier to work with. Good. Now part B looks a bit more tricky. Let's have a read of it. An ornament is made from a solid glass square base pyramid, which is this square base pyramid here. Okay. The base has length 15, which we can see down here. If that's 15, that must also be 15 because it's a square. A hemisphere with radius 6 is cut out of the pyramid. Okay, and a hemisphere is just half of a sphere. This reduces the volume of the glass by 30%. Okay, which means that the volume of the hemisphere must be equal to 30% of the total volume. That could be useful, because if it reduces the volume of the whole thing by 30%, the volume of the hemisphere, this must be equal to 30% of the total volume. Let's calculate the perpendicular height of the pyramid. So you basically want to get the height, and it's perpendicular means that the vertical height, this here, of the pyramid. Okay, that's what you want to go and find. The H written terribly, height. There we go. And the volume is given by this formula, 1/3 times the base times by the perpendicular height. Now, the thing is, we're trying to find this here. That's the height, this part here. That's what you're trying to find. And I don't know currently what the area is. But what I do know is, right, that the volume of the hemisphere, okay, is going to be half of this here. Because the hemisphere is half of a sphere. So I can go and say that, well, the volume of the hemisphere is going to be equal to 288 pi, that's the sphere, divided by 2. And we know that that's going to be 30% of the total volume. So that's going to be 144 pi is equal to 30% of the volume. Okay. Now that's going to bring us over here for a bit more space. Okay, so we know that 144 pi is equal to 30%. I want to get what is like 100% of the volume, because 100% is going to be the volume of the square base pyramid. Now, to go and get 10% here, I can divide both sides by 3. Okay, and divide by 3, because then I'm going to be getting 144 divided by 3 is 48, so 48 pi is equal to 10%. Now to get 100%, I can upscale easily by just timesing through by 10 and do the same thing over here, timesing through by 10, and that's going to give me 480 pi is equal to 100% of the volume. So basically, right, 100, what have I done there? 100% 100%. Okay, so you now know that 100% of the volume is the volume of the square base pyramid. Okay, so we can go and say that now the formula of the pyramid, so the volume of the pyramid, V of the pyramid, okay, the formula is equal to a third times the base times by the height, okay, and the volume of the pyramid is 100% of the volume, okay, so that must be equal to 480 pi. 480 pi is equal to a third times by the base. The base is going to be 15 times by 15, which is 225, times it by the vertical height. Now, that's going to give you 480 pi is equal to a third of 225. We'll simplify, will it? Oh, it does 75 times by the height. Now, to go and get the height, I can just go and do 480 pi divided by 75, and that should give me, hopefully, the height. So 480 pi divided by 75 gives me 20.1. Okay, so 20.1, and it's going to be in centimeters for a height, a length. 20.1 is the answer. Good. Okay, that's quite a nice question. It was unlocking the fact that the hemisphere was 30% of the volume, which meant that if you could get 100% of the volume, that must have been the volume of the pyramid. Good. Question 14, we've got this. And again, when I look at this, I'm thinking bounds straight away because you're getting like this rounding to one decimal place. Anyway, the question is saying, you've got standard bricks have dimensions 21.5 by 10.3 by 6.5 correct to one decimal place. A house is built using 4,663 of these bricks. Jocelyn says, placed end to end, the bricks from the house to the wall would definitely reach over 125. Show that Jocelyn's statement is correct. Now, for this to definitely be over 1 kilometre, you've actually got to go and use the smallest possible value length of the brick and see if it would work out. Now let's just kind of visualize this a little bit, right? So if I've got a brick here, okay, this is a brick, and we are connecting a bunch of these bricks together. So there's one, there's another one, okay, and there's another one drawn absolutely terribly, okay, but I think we get the picture here. Sorry, this is really badly drawn. Getting a little bit of fatigue setting in. There we go. Good. Good. And then there we go. Good. Now, actually, to look at this, we only need to be considering the length, which is the longest number here of the brick, which is 21.5. Okay, so this is actually like looking at bounds now, and the middle number here is 21.5. If you're rounding to one decimal place, we can go above and below it to 21.6 and 21.4, and to get the upper and the lower bound here, we just go in between these numbers, so it's going to be 21.45 and 21.55. Now, for the bricks to definitely reach over 1 kilometre, you want to be using the smallest possible value and see if it still goes above 1 kilometre. Okay. Now, if there's 4,663 of these bricks here, each with the smallest possible value of 21.45, okay, and this is all in centimetres, isn't it? That's a centimetre, so they're all in centimetres, which is not actually very useful. Okay, so this is going to be 21.45 centimetres. Well, let's just go and work it out. So if we go and do 21.45 centimetres, we times it by 4,663 bricks. Okay, what does that give you? 21.45 times 4,663, we get 1,000 or 10. 0, no, that's not even written right. So 1, 0, 0, 0 to 1.35. And this is going to be in centimeters. Okay. Now, to get this into kilometers, well, this is going to be just through like a little bit of logic here. That must be referring to 1.000 to 135 kilometers. Okay, so you can see that because this, with the smallest value of the brick, so if every brick had a length of 21.45 and 21.45, even if all of the bricks had the smallest possible length, you would still get above 1 kilometer. So I've shown that Jocelyn's statement is correct because this value here is bigger than a kilometer. So just to make that clear, you can go and say that 1.000 to 135 is bigger than 1 kilometer using the lower bound of the brick. Part B is this. A standard brick should weigh 2.8 kilograms correct to 1 decimal place. So just straight away, let's just go and get the bound for this because the question is all about bounds. So your number is 2.8, and let's go and put that in the middle. That's going to be 2.8. The upper bound is going to be 2.9. The lower bound is going to be 2.7. So up here it's going to be 2.85 and then 2.75. This is all in kilograms. Good. It's saying a truck can carry a maximum load of 20 tons. Now, you've got different units here, but we need to know that 1 ton is the same thing as 1,000 kilograms. That's important to know. Okay, so 20 tons is going to be equal to 20,000 kilograms. Now, calculate the maximum number of bricks that the truck should be able to carry. Okay, now, this is now saying, right, well, if you had like the maximum number, you want to say, well, if all of the bricks were the heaviest possible value, okay, so if they were all of the heaviest weight, how many of those could you fit into 20 tons, which is 20,000 kilograms? So you can go and do 20,000 and divide it by the heaviest possible weight of the brick, which is 2.85, and that's going to give you an answer of 7,017.54 ... So how many bricks can you carry? Well, it's going to be 7,017 because 7,018 would be over that limit. So it's going to be 7,017 is going to be your answer. Okay, because 7,018 would be too heavy. Now let's check the mark scheme. Yeah, correct. Good. Now, part II is this. Explain why the answer may not be possible to achieve, or could you even fit this many bricks into the trailer or whatever the truck is carrying? Yeah, so something like this. Could you just something like this? Something like, is there enough space in what we're looking at here, a truck, in the truck trailer, I'm guessing, to carry 7,017 bricks. In fact, I've written that like a question. It should be something like this. There might not be enough space in the truck trailer to carry that many bricks. Okay, or something like, could the tire pressure hold up? You know, you just got to put it into real life context. Am I still recording? Yes, I am. Good. Good. Moving on to question 15 is looking like compound interest, which is this. Ratna invests £1,200. Okay, that's her initial investment for 2 years in a bank at an interest rate of R%. Compound interest, that's important. At the end of the 2 years, the amount is this much here, calculate the rate of interest. So important that we know that for compound interest, you've got the your initial starting amount, you times it by the rate of interest or the multiplier, okay, and that is all to the power of the number of years or time. Okay, so this is kind of like the formula in a bit of a less sophisticated written way, but it's still fine. Now the initial amount here is what you invest, which is going to be £1,200. You're timesing it by the multiplier, which is what you're trying to kind of find out, the rate of interest. Let's just go and write that as M, and the number of years is 2 years, and we know that after those 2 years you got a value of 1379.02. Now to get this, we've got to go and divide through by 1,200 because we're timesing by it, so you want to divide the whole equation by 1,200. So m squared is going to be equal to 1379 divided by 1,200, which gives you 1.149166, so on and so forth. To go and get m now, you want to go and square root both the sides to get rid of the square up here, because these are inverse. So m is going to be equal to the square root of this here, 0.149166. So the m is going to be equal to root of this gives you 1.07. Let's just go for 1.072 if I round it. Now this is your multiplier, okay? This is your multiplier. This as a percentage, okay, is going to be, well, 1.072, and you would times it by 100 to get the percentage here, which would be 107.2%. Okay, so what you've done is you always begin at 100%, okay, and they added on a 7.2% rate of interest to get you to 107.2. So the rate of interest, our percent, okay, must have been 7.2%, and that is going to be your answer. So 7.2%. Now we can check this is going to be correct if you go and get your calculator, and let's just kind of work backwards, or work how you would normally work. We know that the investment was 1,200. If we times that by the multiplier, which is, this is the multiplier, 1.072. Okay, 1.072. This is a 7.2% rate of interest increase, because 100% and 7.2% gives you 107.2%, which as a decimal is 1.072. And then to the power of years, which is 2, that would give you, there you go, 1379.02 as required. So that should be good. Checking the mark scheme, we are correct. Excellent. 7.2% is good. Okay, moving on. Box plots. The box plot shows the distribution of salaries of the workers at Bexbridge Biscuits. Okay, state the median salary. Now, just to note on a box plot over here, okay, so that we should know this, what we need to know is the following. Here's your box plot. Okay, you've got some pretty important values and things to know on here, which is, first of all, this top part up here is your biggest value. The part over here is your smallest value. I missed out something on the diagram. You've got this part here is your middle value, which you call the median. This here, you call it the lower quartile. So the lower quartile, which is also abbreviated as LQ. And this up here, you call it the upper quartile, which you can abbreviate as the upper quartile. Good. And also you have, like, your data is in 25% intervals. So 25% of your data is between the smallest value and the lower quartile. You've then got another 25% of your data between the lower quartile and the median. another 25% between the median and the upper quartile, and you've got 25% between the upper quartile and the biggest value. Okay, so it's split up into 25% increments, as you can see. So the median here is this line here, and just going to help me use this to get me to my answer. The median is going to be equal to 37,000. Yeah, they're going up in one, so that's going to be 37,000 for this one. Okay, there we go. And let's go and rub this out. The interquartile range, okay, the interquartile range is the upper quartile take away the lower quartile. So that's the upper quartile take away the lower quartile. So you want to go and get, that's your upper quartile, that's your lower quartile value. Okay, and these values are going to be 43,000. So 43,000. Take away the lower quartile, which is 21,000. Okay, and if you do this, you get an answer of 22,000, and that should be good, and it is good. So 22,000. There we go. Excellent. So perfect. Moving on. Part C. Is this the following salary information is true for workers at Camford Cookies? Okay, so a different company. The highest paid worker is £85,000. So kind of using this diagram. Actually, I'm going to go and see if I can sort of snip this onto the next page. That'd be quite useful. I'm going to try something new, guys. There we go. Add to new page. No, add to library. Okay, and if I go to this, where is my library? Library. Oh, I'm not sure. Anyway, right, let's just draw it out again. So, there we go. Okay, just drawn really roughly, but that's fine. Okay. Now, basically, right, it's saying that the highest paid worker is 85 grand, so that must be this value up here. This is the biggest number, which is 85,000. The lowest paid worker earns 20% of the highest paid worker, so to get 20% of that, you can go and do, well, 20% as a decimal is 0.2, timesing it by 85,000, that is going to give you whatever it gives you. 17,000. So the lowest paid worker is going to be earning 17 grand, which is this person over here, £17,000. 25% of the workers earn more than £50,000. So that's kind of like saying that like the top 25%, so from the upper quartile to the biggest value, is that value, which is 50 grand. So you're kind of saying like the upper quartile here, that must be £50,000. We've done this one, we've done this one, we've done this one. 25% of the workers earn less than £28,000. That's like saying the bottom 25% earn less than the value that they stated, which is 28 grand, which must be here, 28,000. And then they give you that the median, nice, is 37. So I'm just going to go and plot these onto the grid. Okay, so beginning with, let's go for the lowest value, which is 17 grand to begin with, and that's going to be somewhere, if that's 20, 20, 19, 18, 17. Now, the width of this part here doesn't matter as long as you're consistent, right? So this part here doesn't need to be a certain number of squares, but it's just got to look different to the lower quartile and the upper quartile and the median. That's the lower quartile. You've also got so that's the lowest value. You've got the lower quartile, which is 28 grand, which is going to go, that's 30, 28 grand. Let's go up to here. Oh, that's not what I wanted at all. That's 30. There we go. I've drawn this absolutely massive, but that's fine. Okay, that's good. The median is 37,000, so that's going to be going 30, 40, 39, 30, 40, 39, 38, 37, up to here. Okay, I think that's good. It is good. Oh, let's go down a little bit more. Good. And then you've got the upper quartile, which is 50,000 exactly, which is a nice one. So it should be just nice and easy to do. Ooh, using a ruler. 50,000. There we go. Not very well done. £50,000. There we go. Good. And then you've got the biggest value is 85 grand, which is going to be somewhere kind of up here. 85. And I went 3 squares. So I keep doing the same silly thing. 85 there to there. Oh, not drawn particularly well. There we go. Okay, and I just kind of draw up everything together. I've drawn this really wide. I'm not quite sure why I've done it like that, but that's fine. Okay. It should probably be a little bit narrower, but that is absolutely fine. Okay, it should be maybe a little bit thinner, but that's fine. That's good. I've drawn the box plots. Okay, and that is how you would do it. Good. Oh, so I'm just stretching. Perfect. Perfect, perfect, perfect. Just checking it. Yeah, we look good. We look good. Part D, a classic. Make 2 comparisons between the distribution of sales at the distribution of salaries at Bexbridge Biscuits and at Camford Cookies. Now, the key thing here is, right, from a box plot, and it's similar kind of questions with cumulative frequency, but from a box plot, you've got some key things here. Right, you can get the median, and because the median is a measure of it is a measure of average, you've got to be stating this word in your comparison. And you've also got the interquartile range. Right, range is a measure of spread. Okay, so we've got to use these words in context in our analysis using numbers. So the first point, let's go and say that, well, for Bexbridge Biscuits, the first one, the median was 37 grand. Okay, so let's just make a note of this for the biscuit place, for the biscuits. No, was it cookies? No, that was, sorry, yeah, the first one was Bexbridge Biscuits. So let's just go and write BB. Okay, and the second one is Camford Cookies, CC. We're going to go and compare the median value, the median, and then the interquartile range. Just go make a note of a number. So for BB, the biscuit place, the median was 37 grand. Okay, salary, and for the cookies, the salary average was, let's look at the data. The median was 37. They're both 37. Is that right? Yeah, okay, it looks good. Yeah, okay, that's fine. That's just the way it is. They're both equal to 37 grand. And then the interquartile range for the biscuits is equal to 22 grand. Okay, so 22,000. And then for the cookie place, the interquartile range is going to be 50 grand, take away 28 grand, which must be 22,000. Okay, so that's going to be £22,000. Are they both the same? That can't be right. Okay, maybe it is. That's probably the way it is. So you can go and say this. This is quite an interesting one. For both the Bexbridge Biscuits and Camford Cookies, first of all, let's go for the median is the same. You state the number, which is a £37,000 salary, which means on average, because the median is a measure of average, so on average, they get the same wages. So you sort of got 3 key points there, right? You've got, you're looking at comparing the median, right, and you give the numerical value, and then you put it into context on average, because median is average, they get the same wages. There we go. Okay, and then let's go and do the same thing for the interquartile range. Oh, what's going on here? And then for also, right, for both Bexbridge biscuits and Camford cookies, the interquartile range is the same. You state the value, which is 22 grand for both, which means, and because interquartile range, which is range, is a measure of spread, you can go and say, so the spread, or like the variability of salaries is the same. Okay. Again, key things here. You state that you're looking at the interquartile range, you give the numerical value, and because interquartile range is a measure of spread, you talk about that and you put it into context. Now, I've just noticed this is only worth 2 marks. I thought it was going to be worth 4 marks. I probably completely overkilled it. You probably could have just gone and put that the median salaries are both 37 grand, and that will get you the mark, and then the interquartile range is both 22 grand. But better safe than sorry. I didn't really read the number of marks, which is probably a bit stupid, but that's kind of how you would answer it really well. Good. Function machines. Okay, question 17. Here is a function machine. Inputs plus 14 times by 5, you get the output. The output of function A is x. Okay, so that's going to be, the output is going to be x over here. Find an algebraic expression in terms of x for the input of function A. Now, to get the input, you've got to go back in reverse. Okay, so you've got to go back this way. Opposite of timesing by 5 is to divide by 5. And then you've got to go, and opposite of adding 14 is to take away 14 to get back to your input value. So to write an expression in terms of x for the input, well, we begin with the output of x. Okay, you've got to go and then divide it by 5, and then you go and take away 14. And that is your answer. So x divided by 5, take away 14. Okay. Part B, a number k is put into function A. The output is also k. Find the value of k. So if the input is k, the output is also k. So we're just going to be saying here that if you go, and this time, if you put in k into the input, okay, well, k plus 14, that would get you to k plus 14. You then times this by 5, so you times the whole thing by 5. Okay, let's just write this a bit differently. So you begin with k, you add 14 to it, so really here you should go and write, you've got k plus 14. You then multiply the whole of this by 5, and you get the output, which is going to be 5 lots of k plus 14. Okay, so you're saying that, well, if the input is k, the output is the same thing. So you can just go and say that here that k is going to be equal to the output, which is 5 bracket k plus 14. So let's go and say that k is equal to 5 bracket k plus 14. And you want to go and now solve for this value of k. Definitely go and expand the bracket. That's going to be a good thing to do. So k is equal to 5k plus 70. Let's go and get this k onto this side by taking away k. So then you're going to be left with 0 is equal to 4k plus 70. Let's get the 70 over here by taking away 70 from both sides. So minus 70 is equal to 4k. And then to go and get k, well, k is going to be equal to minus 70 divided by 4. Okay, so k is going to be equal to minus 17.5. That should be the answer. So negative 17.5. And let's check the mark scheme, but that should be good. That is good. Excellent. Good, good, good. Moving on. Question 18. Percy sells paint in standard tins and large tins. So paint in standard and large tins. The standard tin covers 40 meters squared. Okay. And the large tin covers 60 meters squared. Okay. Percy publishes this chart showing the area that can be covered with each tin of paint. Explain why the chart is misleading. Well, I don't know why they made the large tin have a bigger width of the bar. So that is why it's misleading. So the width of the bars are not equal. Okay, and that should be it. Let's just check the mark scheme. Yeah, good, that's fine. Perfect. Question part B is this, looking at similarity on the question. So the standard tin and the large tin are mathematically similar. Okay, the volume of the large tin is 50% more than the volume of the standard tin. Okay. Both tins are cylinders. The radius of the standard tin is 10 centimeters. Calculate the radius of the large tin. Now, looking at this first part over here, if the volume of the large tin is 50% more, now that must mean you always begin at 100% of a number, right? If you're 50% more, you've added on 50%, okay, which is going to give you a total of 150%, which as a decimal, because 150% is 150 divided by 100, which is 1.5. So the larger tin, what's happened there? The larger tin is 1.5 times bigger than the smaller tin. Now, let's just write out what is going here. So you've got the standard tin, and you've got the large tin. Okay. And you know that the radius of the standard tin is 10 centimeters. So that's going to be 10 centimeter. Importantly, right, this here is a length. Okay, 10 centimeters is a length. Okay. And we are also being given some volumes here, because it says that the volume of the larger tin is 50% more than the standard tin. Now, let's just go and designate a volume for the standard tin. Let's just go and say it's going to be, I don't know, 1 centimeter cubed. Sorry, 1 centimeter cubed. The larger tin must therefore be 1.5 times by this 1, which would be 1.5 centimeters cubed. Okay, so what's important to also make a note of here is, right, we're looking at our scale factors. Right, we know that a length scale factor, scale factor SF, you call K, okay, and we don't know what this value of K is, and you've also got a volume scale factor, which you call K cubed. And we know, right, to get from 1 to 1.5, you're timesing by 1.5. So your value of K cubed is going to be equal to 1.5. Now, that must mean that to get your length scale factor K, okay, that must be equal to the cube root of 1.5. Now, we're trying to get the radius of the large tin, which is, a radius is a length, so you want to go and get this one up here. Okay. You want to go and get this here. Now, because these are lengths, you cannot times by your volume scale factor. You've got to go and times by your length scale factor. Just get from your standard tin up to your large tin radius, which is your length. You can go and do. Let's do it down here. You can do 10 centimeters and times it through by the length K scale factor, which is the cube root of 1.5. And if you do this, you're going to be getting an answer of 11.4 centimeters. So this is going to be 11.4 centimeters. Okay, and that makes sense because, right, your volume got bigger, so your length must have got bigger, but just at a different scale factor. And checking the mark scheme, That looks good. Okay, 11.4 is correct. Okay, and just to make it clear, if you're like looking at this visually, right, the length radius is of course a length. Okay, because centimeters is a length. Okay, good. I believe we're on to the last question, which is quite a nice one. It's just saying, right, show that this algebraic fraction can be simplified to this. Whenever you get something with quadratics in the form ax squared plus bx plus c, factorize it and then cancel out, and you're going to be good to go. So let's just kind of split this up into two parts. We're going to begin by looking at the top quadratic, okay, which is 2x squared plus 13x plus 20. Now, depending on how you factorize the quadratics, your method might change, but this is how I would go through it. The bulletproof way, this is going to be the AC method because you've got a coefficient bigger than 1. So you want numbers that are going to multiply to give you 40, and that add to give you 13, the middle number, and these numbers are going to be 10. What are they going to be? They're going to be 8 and 5, aren't they? 8 and 5, because 8 times 5 gives you 40, 8 add 5 gives you 13. So I'm going to split the 13x up into this, so 2x squared plus 8x plus 5x, and then plus that 20 on the end. Okay, and I wrote the 8 first because I know I can take out a 2 from 2 and 8. So 13x I've just split up into 8x plus 5x. Okay, so these mean exactly the same thing, just broken up. And then I go down the middle and I factorize each part, so it's going to go to 2. I can take out a 2x and then a bracket x plus 4. Factorizing out the first part. I should have the same bracket x plus 4 over here, otherwise it's gone wrong somewhere. And what can I take out of this? I can take out a 5. Okay, let's just double check it. Is 5 times x 5x? Yeah, it's 5 times 4, 20. It is good. So my two brackets are going to be, I can take out a 2x and a 5 from x plus 4. So it's going to go to 2x plus 5 and also x plus 4. So this is my first quadratic factorized. Do the same thing now with the second quadratic. Okay, we've got to go and factorize it. So we've got 2x squared plus x minus 10. Again, it's going to be your AC method because you've got a coefficient bigger than 1. So numbers that multiply to give you minus 20 and that add to give you a 1. You've got 1x, so 1, which is going to be 5 and minus 4. Okay, 5 times negative 4 is minus 20. 5 take away 4 is 1, so that's going to be good. So we're going to go and split up x into 5x take away 4x. So we've got 2x squared. Let's go and write the minus 4x first, plus 5x and then minus 10. And I wrote the 4x first because I can take out a 2 from 2 and minus 4. Again, that x is the same thing as minus 4x plus 5x. Again, let's go and make a split down the middle. Let's go and factorize out each part. So on left bit, we can take out a 2 and an x again. And we've got x take away 2. Okay, and then I should get the same bracket over here, x take away 2. And I can also go and take out a 5 here. Okay, and it's going to be a plus 5 because 5 times by x is 5x, 5 times by minus 2 is minus 10. So my two brackets are going to be, take out a 2x and a 5 here. I'm going to be getting a 2x plus 5, which is good because that's going to cancel in a second, and an x take away 2. Okay, good. So that's the bottom part. So I can now go and rewrite this as my factorized form. So it's going to be on the top, on the numerator, we got 2x plus 5 bracket x plus 4, all being divided by, on the bottom, 2x plus 5, and then x minus 2. And this, the aim of the game, right, whenever you're simplifying an algebraic expression like this, there should be at least a bracket on the top and the bottom that are the same, because then, of course, you can cancel them out, which you can do with 2x plus 5, and you're just left over with, which is really nice, x plus 4 over x minus 2. Okay, and that is clearly in the form x plus a number, that number is 4, and x minus a number, well, that number is minus 2. And that is your answer. Okay, so that should be completely correct. X plus 4 over x minus 2. And that is the end of the paper, guys. So thank you for watching again. A bit of a slog, but yeah, really good if you followed along, and hopefully it was useful. Of course, you can always comment any questions that you have, but thank you for following along, and keep up the good work, guys. Well done.